looking at an example where we're going to use the ideas of finding the slope of the line tangent to a curve. If we have r is equal to 4 cosine theta and we want to find the slope of the line tangent to the curve at the point 2 pi over 3. Okay, a couple of things kind of to get started that we're going to need. First of all, the derivative of our function. Okay, f of theta is the function r, so we're talking about the derivative of r here. That's going to be negative 4 times the sine of theta. Alright, if thinking about writing parametric equations, we need an x equation and a y equation. X is going to be r times cosine of theta. Y is going to be r times sine of theta. So when we plug in r into that formula, then we have 4 cosine theta times cosine theta for x, and we have 4 cosine theta times sine of theta for y. So x is 4 cosine squared theta. You can write it that way if you want to, and y is 4 cosine theta sine theta. So the derivative, okay, I'm thinking about the derivative of y with respect to x. dy over dx is going to be the derivative of our y equation. So using the product rule there, let's see, first factor times the derivative of the second factor plus the derivative of the first factor times the second factor. And then the derivative of function x. Since I've written that as 4 times cosine squared theta, I can just use the chain rule there. 4 times 2 is 8 times cosine of theta times the derivative of cosine theta, which would be negative sine theta. So cleaning up what I've got, dy over dx is going to be 4 cosine squared theta minus 4 sine squared theta. And in the denominator I have negative 8 cosine theta sine theta. You could actually reduce that fraction, I mean. Cosine squared theta minus sine squared theta over negative 2 cosine theta sine theta. Okay, and then we're going to plug in a value of theta that's pi over 3. And that comes from the ordered pair we were given. So our derivative then is the cosine of pi over 3, which is 1/2 squared, minus the sine of pi over 3, which is square root of 3 over 2 squared. And in the denominator we have negative 2 times cosine times sine. So looking at 1/4 minus 3/4 divided by negative square root of 3 over 2. The numerator would be negative 2 over 4. Or negative 1/2. If I write that as negative 1/2, it's going to be a little bit easier to simplify. So negative 1/2 divided by negative square root of 3 over 2. Invert and multiply, you're going to have 1 over the square root of 3. And as far as I'm concerned, you can leave that in that form. Now for MyMathLab, you probably will need to rationalize that equation, or that fraction. So the slope of the line tangent to our curve at the point 2 square root pi over 3 is 1 over square root of 3. Next, let's find a point where the curve intersects the origin, or goes through the origin. Okay, think about it this way. That's going to be the case anytime r is equal to 0. So set 4 times cosine theta equal to 0 and solve for theta. So think about the unit circle, and we know that cosine is 0 here and here. So that's going to correspond to angle measurements of pi over 2, 3 pi over 2 if we're talking about the interval from 0 to 2 pi, and others, anything coterminal with pi over 2 and 3 pi over 2. So the tangent slope at, let's say, theta equals pi over 2 will be the tangent of pi over 2, which is undefined. Okay, which means the tangent line is vertical at theta equals pi over 2. Okay, so the equation, this actually is the equation of that tangent line, and it is a vertical line. Now, other things that you may need to think about. Okay, remember that tangents are vertical when the denominator of our slope is equal to 0. So that's going to be when the rate of change of x with respect to t is equal to 0. Actually, with respect to t makes no sense. X is a function of theta. So dx over d theta is equal to 0. Alright, so with our example, the denominator, the bottom part of our fraction for slope of a tangent, was negative 2 cosine theta sine theta. If I set that equal to 0, I'm looking at values of theta for which cosine is equal to 0 and values for which sine is equal to 0. So we're talking about pi over 2 and 3 pi over 2 for sure, and also 0, pi, 2 pi. Okay, and of course anything coterminal with any of those angles is going to have a vertical tangent as well. Tangents are horizontal when dy over d theta is equal to 0. So the numerator of our slope formula was cosine squared theta minus sine squared theta when I reduced it. Set that equal to 0. Okay, now to finish this, it's going to be helpful to recognize that that is one of the identities for the cosine of 2 theta. So thinking about cosine of 2 theta equal to 0, then 2 theta would be pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Okay, these two come from the one rotation around the unit circle. Those two angles come from a second rotation around the unit circle. And because I'm looking at 2 times theta, I look at 2 rotations. Then solving that for theta, we'd get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now it's a good idea for you to use your calculator and graph the polar curve for cosine theta and take a look at where on that curve the point is when theta is equal to one of those angles. And you will see that if you imagine drawing a tangent line there, it would have to be horizontal. Same deal for this. It would be a good idea for you to graph your function and take a look at what point on that curve, where on the curve is the cursor when you evaluate at these values of theta. You'll see that you're going to have vertical tangent lines there.